Hello viewers, in today's session we are going to discuss an important problem from continuity of functions. So here we have a function which is defined as x times greatest integer of x cube minus kx square for x greater than or equal to 0 but less than 2, and f of x is equal to x minus k times x for x greater than or equal to 2 but less than 3, right? And we have to find the value of k in if f of x is given to be continuous at this point x is equal to 2. So here this function f of x is given to be continuous at x is equal to 2, right? So we know that a function is said to be continuous if the left hand limit is equal to the right hand limit and both these limits are equal to the value of the function at the given point, right? So here we are given x is equal to 2. So the value of a is 2, right? So a function is said to be continuous if the left hand limit exists, it is finite. Similarly, the right hand limit exists and it is finite, and both the limits are equal to each other and they are further equal to the value of the function at the given point, right? So here what we will do, we'll first find out the left hand limit. So the notation for the left hand limit is limit x tends to 2, and here we will put a negative sign, and here we have f of x, right? So here we have the point a is equal to 2, and in the left neighborhood of x is equal to 2 we have a point which is very close to a is equal to 2, and this point is 2 minus h, and we have a point in the right neighborhood of x is equal to 2, which is 2 plus h. So when we find the left hand limit, it means we are approaching from the left of x is equal to 2, and when we are calculating the right hand limit, it means we are approaching from the right of x is equal to 2. So the left hand limit is given by limit x tends to 2 minus, and here we have f of x. So we'll take x is equal to 2 minus h, right? So when x tends to 2, then obviously h tends to 0, right? So we have limit h tends to 0, and we have f of x is 2 minus h, so we have here 2 minus h. So now we can easily find out the value of f of 2 minus h from this expression, right? Because see here the function f of x is defined as x times the cube of greatest integer of x minus kx square for all values of x which are less than 2, right? So when x is less than 2, it means 2 minus h is less than 2. So we'll make use of this form of the function for getting f of 2 minus h. So we have now 2 minus h. Here we'll take x is equal to 2 minus h. Here we have 2 minus h cube minus k and 2 minus h square, right? Okay, so now we have to evaluate this limit. Now see here we are having a term greatest integer of 2 minus h. Now see this quantity h is a positive quantity and it lies between 0 and 1. Now h is infinitesimally very small quantity. So it is so small that it is very close to 0, and when we subtract h from 2, then this quantity 2 minus h is slightly less than 2, but it is greater than 1, right? So 2 minus h is greater than 1 but less than 2. So the value of greatest integer of 2 minus h is equal to 1. So here we'll take the cube of greatest integer of 2 minus h as 1 cube. So we have limit h tends to 0, 2 minus h. Here we have 1 cube minus k and 2 minus h square, right? Okay, so now when h tends to 0, this limit may be obtained by replacing h by 0. So we have 2 minus 0, 1 cube is 1, here we have k, here we have 2 minus 0 square, so this is 2 minus 2 minus 0 is 2, 2 square is 4, so this is 4k, right? So the left hand limit is equal to 2 minus 4 times k. Let us find out the right hand limit. So now the right hand limit is given by limit x tends to 2, and here we have a positive sign and we have here f of x, right? So when we calculate the right hand limit, then we take x is equal to 2 plus h, because 2 plus h is greater than 2, and we are now approaching from the right of x is equal to 2. So all the quantities which are 2 plus h are greater than 2, right? So when x tends to 2, then h tends to 0. So now this limit reduces to in terms of h, that is h tends to 0, f of 2 plus h. So now we calculate, or will write the value of f of 2 plus h from this expression, because see here we have x greater than or equal to 2. So the form of f of x for x greater than 2 or equal to 2 may be taken as x minus k times x, right? So f of 2 plus h is obtained by replacing x by 2 plus h. So we have 2 plus h minus k, then we have here 2 plus h, right? So now we have to simply substitute h is equal to 0 in order to calculate this limit. So we have 2 plus 0 minus k, and here we have 2 plus 0. So this is 2 minus k, and here we have 2. So this is 4, 2 to the 4, 2, 4 minus 2k. So now the right hand limit is equal to 4 minus 2k. Now let us calculate the value of the function at this point, that is x is equal to 2. So f of 2 can be obtained by taking x is equal to 2 in this expression, because x is greater than 2 or equal to 2, f of x is defined like this. So we have 2, then here we have 2 minus k, and here we have 2. So this is 4 minus 2k. So now the function is given to be continuous at this point x is equal to 2. So the left hand limit should be equal to right hand limit, should be equal to f of 2. So right hand limit, left hand limit is 2 minus 4k, right hand limit is 4 minus 2k, and f of 2 is 4 minus 2k. So now these two quantities are same, so we can frame an equation in k by taking these two quantities, right? So we have 2 minus 4k is equal to 4 minus 2k. Now taking minus 2k to this side, we have 2k minus 4k, 4 minus 2, so minus 2k is equal to 2, so k is 2 over minus 2, that is minus 1, right? So the value of k, if the function f of x is continuous at x is equal to 2, is given by k is equal to minus 1.